All right, thank you for listening to this video. We're here with our stats class talking about making a scatter plot with our data about the height of the initial drop for a roller coaster and also how long the roller coaster lasted. So we're looking to see if there's something going on between these two quantitative variables. All right, when I look at the data, I notice immediately that they're quantitative because if you look at drop and duration, it gives their units to the side. So these are quantitative variables, and I would like to make a scatter plot to see if there is some kind of relationship here. Now, the first thing I ask myself is, which one do you think is the explanatory variable? Do you think that the height of the first drop explains how long the ride lasts, or do you think how long the ride lasts explains the height of the first drop? Bless you. All right, I agree. I think the height of the first drop, so drop explains duration. So I'm going to use for drop is going to be my explanatory. So that's going to be the x, and my duration will be the y. All right, so I'm going to go to Desmos. Okay. And when I look at it, I've already typed in all of my data values. You'll notice you shouldn't see anything yet because we need to change our axes and scales. So if I go to the wrench, the x-axis, what is going to be the minimum value on our x-axis? 86, so if we use 83, we should probably see it. What about our maximum for our x-axis? Yes, question, I'm so sorry. Did I miss one? Yeah. I'm so sorry. Which one did I miss? Ghost Rider, 108 and 160? Thank you so much. All right. So what was our lowest value again? I'm going to use 83. Our highest, 300, right? So 303. What about our lowest for our y value, our duration? 65, so you put 60, okay, I'm going to put 63. And then our highest or longest y value, 240. Okay, we should see it. And there it is. Now, where is my 240? Am I missing it? There she is. All right. Okay. Now, so I get a lot of students that say weak because you think it's really spread out. Fair enough. All right. But we need to include a couple more things, right? If we look at the scatter plot, we should be thinking about three things. Weakness is talking about how strong it is. That's strength. What are the other two? Direction and form. I heard Shirley say, is it linear? So linear or not, and then that would be for form. And then direction, is it positive or negative? It looks like it is slightly positive, right? The higher the drop, the longer the ride is going to take, which makes sense. If it's a longer drop, usually it takes longer. Okay, so when you're writing your sentence, and Leslie F., like you asked on Tuesday, if you look to the slide to the right on your notes, you should have room to write this sentence. So I'm going to scroll over and write it. All right, so there is a, I'm going to do it there then. There is a, yes. Judge the what? So you can always write what you think, and then when we calculate R, then we can go back and change it if we want. Okay? So I heard people say weak. I'll go with that. There is a positive. Do we think it's linear? We don't think it's linear? No? Not linear? Okay. Okay, I think it's linear, so I'm going to write linear. I'm not you. There's a positive, linear, weak association between the height of the first drop. Let's see if I can do this. That's what he thinks. That's what I'm putting. You're not me. Put whatever you want. Between the height of the first drop and the duration of the ride. So something like that. If your words are not the same, it's fine. If you don't think it's positive, linear, or weak, that's fine. right? When I grade your quizzes for this week, I'm not going to be, there's not like one set answer key. All right? Now, when we calculate the correlation coefficient for R, there will be an exact answer for that because that's from Desmos. Are there any questions so far on this process? Now, the reason I say it's linear is because if you don't say it's linear, you shouldn't go any further. But I would like to keep going. I think it's linear. So I'm going to go further and actually find the correlation coefficient. So I'm going to go to Desmos. Go back, hit these two little arrows here, the show list in the top left corner. All right, and I want to go to the next line there, and I want to actually put in what's called the linear regression model. And again, as I mentioned on Tuesday, this is something we're on purpose not going to talk about this week and talk about it next week. All right, but I need to do this in order to get the letter R, the correlation coefficient. All right, so I'm going to use Y, hit the keyboard, that show keypad button, to get to the subscript, which is next to the 1, 2, 3, so subscript 1, Y sub 1.
For me, if I just put the 1,
it makes it a subscript. Excellent. Let me see if I can do that. So you just put 1 and makes a subscript? Well, let me get out of there. Okay. Oh, interesting. All right. It already knows what you want to do. Nice. You don't do that anymore. Cool. Now, we don't want to have the equal sign. We want to put the approximate, which is a little bit further to the right. This one right here. It's going to put that in. Then we are going to use our slope-intercept form. M x sub 1. Let me see if I do 1, if it does it as well. Nice. Very cool. Thanks, guys. And then plus b. Okay, and then you want to lower the keypad. And I'm going to do this just for a second. I'll go back, don't worry. Well, so when I look at it, you guys said weak. And what is my correlation coefficient R? I know it's kind of hard to see down here. That's right there. It's 0.352. That is weak. That is weak. So when I write down my R equals 0.325. That is weak. I would agree. It's close to 0. Really, I need to be more near like about 0.5 to get to the moderate. So I would agree that this is weak. But I still think there's a linear relationship, even though it's weak. Because I think that I've been on roller coasters in my experience. The longer the first drop, the longer the ride is. All right, I think there's a weak relationship there. Now, what that means is if I think there's a relationship going on, clearly there's other stuff that is going to impact the duration of the ride. What are some other things that will impact how long a roller coaster ride is besides just the height of the first drop? How fast it goes? The weight, yes, and I think I heard drivers who said how many people, which is kind of weight related. Have you guys have you guys been on a lot of roller coasters? Yes? You know how like the different ones where you sit down or you're standing or whatever? Like I think that affects the design of it, how many like flips you can do. Some of them you can't do flips. It's like dangerous. How new it is? I always think like if it's been built newer, better technology, maybe it can go faster so it's over quicker. I don't know. Magnets? What about magnets? Oh, they use magnets instead of... Oh, so those wheels actually used to be doing something before? Oh, man, I did not actually. I thought it was always been magnets. That makes me scared. Okay, much more scared than this weather. Okay, so now, after you do this, if you want to change anything, you can. But ultimately, this is the process. Okay? Now, what we're going to do when we shift to next week is when we're going to be looking at how to then make a model. Okay, that's the goal of next week. Are there any questions about this process compared to what we did last time? Between Tuesday and now, when we did the miles per gallon? Any other questions on this? Yeah. Yes? It's up to you, right? I mean, you think it's not linear. I think it's linear, but just a weak linear relationship. Like when I look at it, it's definitely spread out, like there's more scatter, so it's weaker, but I still think it's going in a linear direction from bottom left to top right, which is why I wrote positive. All right? And then what you can do, Catherine, is if you really are worried about it, just make sure you look at the correlation coefficient as well. right? Because if that R would have been 0.1, maybe then it's so weak that it's not even worth calling it linear. Okay? All right. Any other questions? Okay, so let's go ahead and